Okay, so we're talking space and distribution, and this is what you read about in chapter 3. Okay, which in your reader, I really like the way it talks about distribution and density. It's a little bit easier to understand in that book than it was our old textbook. So I thought that was kind of nice. Okay, so when we talk distribution and density, though, we need to make sure that we understand the difference between those two. So I'm just going to add a definition for both of those here at the top of your page. So just write this at the very top. Okay, so the first one, distribution. Okay, so when we talk distribution is the arrangement of something, and in this case, people. Okay, so the arrangement of something across Earth's surface. Okay, so when we talk distribution, that's big picture. Okay, so that's like the whole Earth. It's global scale. Okay, but then when we talk density, we're going to focus in. Okay, so density. Okay, density is frequency with which something, again, in this case, people, exists within a given space. Okay, so density is actually a characteristic of distribution. Okay, so distribution, big picture. Density, we focus in on an area. Make sense? Okay. All right, so you read about arithmetic density, physiological density, and agricultural density. We say arithmetic because it's fancy. It's AP Hug. Okay, so we don't say arithmetic. We say arithmetic. Okay, so I'm gonna get some stuff drawn into those boxes for each one, just to kind of try to make better sense of what those are. Okay, so for my first one, arithmetic density. There's nothing special about this density. Okay, it doesn't give you the whole picture, it just gives you a little piece of it. Okay, so when we're figuring arithmetic density, we take all the people that the country has and we divide it by all of the land.
So where do we put this above that box?
Yeah. Okay, so for this I'm gonna focus on the Nile because it kind of makes sense when you think about Egypt as a big picture. Okay, so just, draw some squigglies. That's the Nile. Okay, now when we're looking at arithmetic density, the reason that I say that this doesn't give you like the whole picture is because arithmetic density assumes that all the people are divided equally with all the land. Now, is that really true? No. Okay, so this would be if every single person in Egypt had an equal amount of square miles or square kilometers, depending on what you're working with. We're really the only ones that don't work in kilometers. Okay, so what you get when you have this number is you get people per square mile. Now, when you read in chapter 3, and I know this was a while ago, okay, it gave you like that little table that talks about all the densities, and it, trying to find it. It says for just your arithmetic density, the numbers that they were looking at for Egypt, it was 226 people per square mile. Okay, well now let's think about this. What do we know about Egypt? It's mostly desert. Okay, talk to me about Egypt's development. Yeah, they're really kind of, I would say like a low NIC, a high LDC. Okay, so not a lot of development. Okay, so we know that there are a lot of people living in the desert?
Yeah.
No. No, it's too hard to live in the desert. People choose to live where it's easy. So then where do most of the people in Egypt live?
Close to the river.
Yeah, close to the river next to the Nile. Okay, so when we look at this arithmetic density, that does not give us the whole picture. Okay, so when it says 226 people per square mile, while that definitely can show that it's crowded in some places, it doesn't show the whole picture that we know that all the people actually live next to the Nile. Okay, all right. So that's arithmetic density. Okay, now physiological density, we get a little more of the picture. Okay, so for this one, we're still taking all the people. So still all the people the country has. Except for now, instead of dividing it by all the land, we only divide by the arable land. What's arable land? Plant on, yes. It's the land that you can plant on. You can grow stuff on it. Okay, so we try not to live on the land we grow stuff on because, food. Okay, but this gives us a better picture because now it's showing us how much stress a country could possibly be putting on their land. Okay, so I'm still doing my Nile. So get your squigglies. Okay, but instead of using like this whole area, now I know that I'm only using a little bit. Okay, so we're not using any of this. Okay, so now that tells me how big of a stress Egypt is putting on their land. So if I go back in the book, it said that Egypt's arithmetic density is 8,000 people per square mile. Okay, so now we've gone from 226 people per square mile to 8,000 people per square mile. Now, we already said Egypt is a desert. It's got a lot of desert. Okay, except for right there by the Nile. So now that makes sense. I can start to see my bigger picture here, and I can start to tell, oh, okay, well, that must be because Egypt's a desert. I know that. Okay, so I know they're not actually living in the whole country. They're living more close to the Nile. Okay, so that's physiological density. And then to get an even better picture, we look at agricultural density. Okay, so agricultural density, now we're only taking the farmers, just farmers. Okay, so all the farmers. And then we're dividing by arable land. Okay, so that's going to give us a little bit of a different picture. Okay, because so if we're looking at farmers and we're looking at how many, it's like a ratio, how many farmers to farmland. Okay, well, if it's a huge number, like Egypt's would be, I want to say it's somewhere around 250. Okay, so 250 farmers per farmland. Okay, so what does that tell me? Because you already told me something about Egypt's development. You said what about Egypt? What? Yeah, so they're a low NIC or a high LDC. So lots of money? No. Okay, so why does it make sense then that there would be so many farmers for the farm?
There's not other jobs.
Well, there's not other jobs, yes, but there's something else. Well, that's kind of going along the lines of what we just said. There's something else, though. No. Then shouldn't we have less farmers if it's desert?
No. There's not enough land. Because it's only a small part that's arable.
No. Let me put it like this. The U.S., 1.7 farmers per farmland.
Per square mile. Big is a farmer.
So why? Don't we have really big farms?
Yeah.
So why don't we have 250 farmers per square?
We have more land. We have more urban areas.
Tractors and stuff.
What?
Like the machines.
We have machines. Our farming is mechanized. Okay, the farmer gets on his plow, his tractor, and he farms. by himself. Okay. Do they have that in LDCs and NICs? No. So why 250 farmers per square mile of farm?
No infrastructure.
Yeah, they need that many people because they don't have the plows and tractors. They need that many people to compensate. Make sense? Okay, so when we have countries like Egypt, they're going to have lots of farmers per square mile of farmland. I'm just going to draw some plants. Okay, and that's because they are not a very developed country, so they can't afford all that. I don't know what kind of plant. This might be corn. Okay, so this shows us number of farmers. This is our ratio. Number of farmers per square mile or kilometer, just depending on what you're working with. Okay, so this lets us compare development. And I'm just going to put dev. Okay, but that lets us compare development, okay? So, like, let's look at Singapore. So, we know that Singapore is teeny tiny, okay? And their population, or excuse me, their arithmetic density already is 20,000 people per square mile. Okay, so that's a lot, okay? But then, when you look at their physiological density, it's 2.5 million people per square mile. So then what does that tell us about Singapore?
They're urban.
Well, yeah, they're urban, but what?
There's barely any arable land.
Yeah, there's barely any arable land, which in the book it says 0.8% of arable land. Okay, that makes sense. Okay, so, but we know what about Singapore's development? It's developed. So can they get around the fact that they don't have a lot of arable land? Yeah, because what do? Yeah, they trade. They import everything. That's fine. I'm just going to import my food because I have the money to do that. Okay, but like say, for example, you're Bangladesh, okay, where your physiological density is 5,000, okay, is it harder to get around that? Why? Because you're less developed. You don't have as much money. Okay, so you're going to put a bigger stress on your land that you do have. Okay, makes sense the difference between the two? Or between the three? Okay. All right. So then let's kind of fill in some stuff down here. Oh no. That's okay. Okay. So let's add a guy. Okay. He's a German philosopher, so we say his name fancy. Okay. So it's Immanuel Kant. Now here's his dates: 1724 to 1804. So he's right in the middle of what? Yes, he's right in the Industrial Revolution. Now, here's why he's important. Okay, so he starts looking at, so he says, okay, well, historians, they're always looking at time. That's really important for historians. Okay, but geographers or people that are looking at geography, they always consider space. Okay, spatial stuff. All right, so he's the first one to get people to take geography seriously. So he says it's as important as history because, at this time history is like, the big deal. Okay, so he's the first one to say that. So makes geography important. Okay, so then that leads to our next question. Why did geographers prefer to organize their material spatially? Okay, well, it's so they can see patterns, concentrations, and density. Okay, so this is the why of the where. Okay, that is the why of the where. When we look at patterns, concentrations, and density, that's what we're looking at. Okay, so then our last question, the arrangement of features in space is known as what? Distribution. Remember, one more time, distribution, big picture. Density, we focus. Okay, so now we're going to look at these bottom three. So we've got three choices: concentration, pattern, and density. So we're just going to fill in the blanks for each of those. Okay, so the first one, what do you think?
Concentration. No, pattern.
Pattern. Whoops. Yeah, this is pattern. Okay, and here's why. Because there's consistency there. Okay, there's like a nice arrangement that we see on there. Okay, so this is pattern. No, this first one. This first one is pattern because of the consistency. It's kind of like this room. Okay, there's a pattern, all right, of desks. Okay, or any room for that matter. Okay, now the next one. Next one's easy.
Concentration.
Yeah, that's concentration. I think in the book it said cluster. Okay, so, and that's because of this right here. That's why it's a concentration, because we see a concentration. It's all filled in. Okay, now you would see this like in college towns. Okay, there would be a concentration of houses and people around the college. Because why? Yeah, they want to be close to the school. Okay, so you would see, sometimes you'll see the same thing like in real small towns, like around a church. You would see it like that. Okay, or even airports. Okay, you would see around airports. Okay, and then so this last one, that's density. A lot of times you'll see this, sometimes you'll even see it like in a line. Okay, it's very linear. All right, so definitely you would see that around like rivers, transportation routes, like really for a long time Frisco looked like this because of the Dallas North Tollway right there behind our school. Okay, so it was a long time like that before the west side was fully like, well now like it's houses everywhere. Okay, but this is kind of like the newer side of development. Okay, okay, so let's think about this question. If we wanted to measure the frequency, okay, or occurrence of car accidents in your neighborhood's busiest intersection. So like, what's that over there?
Right by War.
No, I'm going the other way.
Main Street.
El Dorado and
Parkway.
423. That's pretty busy. Like close to the Walmart.
Yeah.
Yeah. Okay. So, all right. So, right. Let's say we're looking right there. What type of measurement would we be finding? Would it be pattern, concentration, or density? Okay. I hear a lot. How many say pattern? Okay. How many say density? Concentration? Okay. It's pattern. Why?
Because it's kind of consistent time repeat when it at 4 o'clock or something. It's when it really gets busy and then it stops.
Yeah.
And then the next morning at 8 it gets busy.
Yeah. Yeah. So you're looking at over time. Okay. You're looking for that. Is there a pattern? Okay. This isn't saying that necessarily there is one, but we're looking for one. So you're looking at all the rush hour times, right? It's like 8 in the morning, 4 or 5 in the afternoon. Okay. But then you look again the next day at those 2 times, and then you look again the next day. Okay. So this is over time that we're measuring. Make sense? No? Yes? Okay. Okay, remind me how I figure out arithmetic density. Okay, so total people divided by total land. So all the people and all the land. Okay, I'm going to give you the population numbers. Okay, so you don't have to worry about looking up those. But you're going to tell me what the numbers are. Okay, so for the U.S., and this is pretty current, our population is 323,995,5 528. Okay, so somebody plug that in for me. What number am I going to put in first? The people. So somebody put in 323,995,525. Okay, and then we divide it by what? Total land. So then divide by 9,826,675. What's the number?
32.97.
Yeah, I'm just going to put 33. Okay, so that's 33 people per square mile. But see, this is arithmetic density, so does that give us the whole picture? No, because do we know, like, say, for example, in New York City, are there more than 33 people per square mile?
Yes.
Yeah. Okay, but like in Wyoming, maybe one people per square mile? I don't know. Maybe 0 in some places. Okay, so that just gives us an idea. Okay, so now you go and figure the rest. So I'm going to write up the population numbers for you, but then you go ahead and start figuring out the rest, and then you're going to answer 7 through 12 with your group. Okay? Okay, give me numbers.
198 for Switzerland.
Yeah, 198 for Switzerland.
123 for Poland.
123 for Poland.
143 for China.
Man, you're on fire today.
And 8 for Russia.
Oh, 8. So who's got the lowest arithmetic? Russia. That makes sense because why?
It's big.
Yeah, Russia's really big.
No, have that.
Yeah. I think it's something like 11 time zones. Yeah. So like it's already tomorrow. Like when you're in one part of Russia, it's already tomorrow in the other part of Russia. Yeah. Okay, which one has the highest? Switzerland. And that makes sense because why?
It's small.
Yeah, it's really little. Okay, so let me know. What would you say that it's better or worse to have a higher or lower arithmetic density? Like, which would you rather have? Why lower? More space? But besides space, what else would you have more of?
More land.
Well, that's space. Well, we're close. Tell me about farmers.
There's more arable land.
Well, there's more arable land for your people, which leads to more. What do farmers do? Food. So there's more what? Food. Okay, there's more resources for you, right? It's more resources, more space, more stuff. Yeah. Okay, so that's what I would say. So more resources and space. Okay, so then number 10, true or false? A large population means a country has a high density.
False.
Why?
Because you may have a lot of space, so it may not really take up. It may not be a dense area. If you
Yeah.
have a lot of people.
Yeah, you might be Russia. Yeah. Okay, true or false? The arithmetic density is correlated to wealth and poverty. False, because why?
Because it just counts people. It doesn't count their standard of living.
Yeah, like who has a really, really high density, but they're also developed?
China. Or not
Switzerland.
America.
Singapore. No, ours is only 33, remember?
Oh, yeah.
Okay, true or false? Arithmetic densities can help us compare the distribution of people in different countries.
False.
True. But is it the only thing to look at? No, but it does give us an idea, right? Yeah. Okay, so let's look at physiological then. All right, so true or false, or not true or false, high or low? Okay, so a low or high physiological density may mean that a country has a greater capability to grow enough food to sustain its population.
High.
Low. You want it to be low because then you know you've got more people that you can support with your arable land. Okay, so it says if we know that the total land area of the U.S. is 9,000,000 826,675 square kilometers, and they have 18.01% of arable farmland. How many square kilometers of arable farmland does the U.S. have? So what am I going to be doing?
Peeps divided by land.
Wait, but we're trying to find arable land first.
Farmers.
We're going to multiply. So everybody do this right now so I know that you've at least done it one time. Okay, so type in 9,826,675. So there's the land. Okay, and then we're going to multiply. So times 18.01, and then touch your percent sign. See how it changes?
Yeah.
Now say equals. Okay, what does that give me?
1,769,784.
0.17. We do decimals on this one. Okay, so that gave me 1,769,784.17. Okay, so that right there, that number, that is our arable land. Okay, does that make sense how we got that number? So what do?
Put in the.
You multiply.
We multiply. We multiply. Okay, so let me give you the numbers then so that you can go ahead and start multiplying. Okay, so for Switzerland, their kilometers, they're 41,277. Their percent is 10.2. Okay, and then Poland's is 312,685. And they're at 36.2. China's is big. 9,596,961, and they're at 11.3. Oh, and then there's Russia, that's bigger. 17,098,241. No, 2. And they're at 7.3. Okay, so tell me when you have them. Yeah. Okay, there you go. So that right there gives us what again? That's the arable land. Okay, that's our arable land. So of all the land that those countries have, only that is arable. Okay, so they can farm on that. Okay, one more time. How do I figure out physiological density? Yeah. Yes. So total peeps divided by just the arable land. Okay. So now I want you to use the current population, which I gave you on the other side. So for the U.S., remember that was 323,995,528. Oh. Okay, so we know arable land now because we just figured that out for each country. Okay, so somebody do this for me. Okay, so let's type in 323,995,528. Okay, and then we divide by what? What was that?
4,000. Wait.
U.S.
1 million, 769,784.
Yeah. Yep. 0.17. Okay, so what does that give us? What is it? 183. Yeah. Okay, so 183 point. Oops, yeah. 0.07. And that's square. Actually, that's square kilometers because we're working in kilometers with this one. Okay, does everybody see how I did that? Okay, so that's what I need you to do for the rest of them. Okay, so there's your physiological densities. Okay, so now that we know those, let's answer these questions over here. Okay, so Nick, which countries that we've just went through has the lowest physiological density?
Russia.
Why?
Because they only have 114 people per square mile.
Well, I know, but why is it so low?
Because they have a lower population and a lot of land.
Yes, yeah, because they have a large country and little people. Well, not little people, but okay, so large country. Low pop. Okay, so then what exactly does that mean, Dalton?
Like for like, what is the?
So what does it mean since Russia has such a low physiological density? What does that mean for them?
There's more space, like more food.
Yeah.
Like available jobs and stuff.
Well, not jobs. Yes, there's more space, more food. So what does that mean about the land?
There's more land.
Well, the land can do what? Support. The land can support the people. So yeah, more space, more food. All right, who had the highest physiological density? Switzerland, yeah. Okay, so then what does that mean, Adam?
But it means that there's not a lot of room. There's too many people, and land might not be able to support people.
Say, I like how you said that last part. The land what?
It might not be able to support people.
It might not be able to support the people. Yeah. So land might not. Why do I like the might not?
Because it could.
Yeah, it could, and it does because Switzerland's a what?
NBC.
Yeah, they're an MDC. So can they get around that? Yeah, yeah. Okay, so land might not be able to support the people. Okay, so then what do you think's better? Should we have a higher or lower? What's better?
Lower.
Yeah, it's better for lower. Because why?
There's a higher chance
The land can support
to support
Higher.
Yeah, a higher chance to be able to support the people. I like that. Higher chance for the land to support people. Okay, so then true or false? A large population means a country has a high density.
True.
False, because like Russia, right? Okay. True or false? The physiological density is correlated to wealth and poverty. False, because like Switzerland, right? I mean, they have a high one, but they're also an MDC. Okay, so true or false? A low physiological density means that a country may have an easier time growing food. True, because that's what we just said. That is that right there. We just said that. All right, good.